Now, much like foreign language, drafting and CAD have a whole set of rules in terms of how they are used, right? And in our case, we need to follow these rules if we're going to communicate information effectively. Everyone's got to be on the same page. So there's a whole set of rules for creating lines that we're going to try to follow. Now, I'm going to caution you, there is an issue with this, and that is when you draw things by hand, you can control exactly how long something is or how short something is, the exact position. When you draw something using a computer, the computer does a lot of things for you. That's the automated part of it. And as a result, sometimes these rules can be hard to follow. So do the best you can, but keep in mind if you're having too much difficulty doing something, most of these rules can be bent. Perhaps not broken, but bent. So in terms of hidden lines, we know the hidden lines are going to represent any type of edge or any type of boundary or surface that cannot be seen. Now, the first rule in creating hidden lines is associated with the length of the dashes. It turns out the dashes are pretty much standardized in that they should be around 1/4 of an inch. But when you have very large views or very small views, you might want to adjust the size of the dashes so that they match the view size a little bit better. So these can be just higher or lower. Now, one thing about this is what you don't want to do is have many different dash sizes all over your drawing. So when you're making an adjustment, you should be adjusting all of the hidden lines on a view or most of the hidden lines on a drawing, and so that there isn't any confusion about what they represent. Rule 2 is that hidden lines should always end and begin with a dash, right? So where they hit the surface, they should have a dash, not a gap. Where they intersect with each other, they should touch as dashes, not at a gap. Now, there is one exception to that rule, and that's if it's a hidden line that essentially doesn't touch the other surface, right? So if there's a parallel line here, then you do want to show it with a dash. And the reason why that is you don't want it to be confusing, right? We want to make sure that this hidden line and this visible line are not connected with each other. Right? Same thing with this little step over here. We want a dash there so we know that these two aren't part of the same line. If a dash touched there, there could be some confusion. Is there some sort of jog in the visible line perhaps? So by having a dash there, we clearly show that the hidden line and the visible line are two different things. Anytime two hidden lines connect with each other, they should be joined by dashes, right? So we see here dashes here, we see dashes here, right? That works out pretty good. AutoCAD's pretty good about doing that. But again, you can adjust the size of the dashes to make that happen if you need to. Now, I mentioned the center lines are used for holes, but they're also used for round notches, and they're also used for symmetry. So when we take a look at this part here, we can clearly see that this part is a reflection of itself, right? It's the same on the left and the right, just with the reversed orientation. So this would be described as a symmetric part. And this line down the middle here, this is a center line, is going to show the line of symmetry. And to show you that it's not a feature of the part, it's just to show its feature, they use these two double thick dashes at the end to show that this is an axis of symmetry between these two halves. By the way, we also use center lines here for that center of that circle, center line here for that center of that circle, and a center line down the middle for this slot. Now, a couple things to note about center lines. Obviously, they should cross at the center. They should run down the axis of symmetry for this cylinder, but you'll also notice they hang over the edge. They extend over the edge, right? Extend over the edge approximately 3/16 of an inch. Right? These are actually a little long, in my opinion. So a little bit better over here. But the whole point of these is to show us that it's a cylindrical shape. It can be a solid cylinder, or it could be a hole, and we use the same basic technique for that in terms of center lines. And again, generally, it's one long line, a short dash, and another long line. Now, once a center line gets very long, you'll probably see long line, short line, long line, short line, long line, right? Because we want to break it up a little bit and want to make sure everyone knows it's a center line. Now, keep in mind the center of circles aren't necessarily always rectilinear. So, for example, in this setup here, this is known as a bolt hole circle. There's actually a series of circles around each other. So this is a circle of centers, or often known as a bolt hole circle, right? And you'll notice in this case, we use a center line, and this center line crosses at the center, but this center line is a circle, right? So this is one of those things that's pretty hard to pull off in AutoCAD because it's hard to get the dash to line perfectly. But again, you can play around with the creation technique to try to get this to work out. And if you ever have any questions with it, you're really trying to make it happen, again, you can talk to me or one of the embedded tutors to show you some of the tricks to how to create that. Another place center lines are used is if you have something that's going to move. So for example, this looks like a wiper of some type that's going to rotate about this axis. We can use a center line to show this path of motion. The first rule in creating center lines is that center lines should always end and begin with long dashes. So for example, here where we have a relatively small hole, we have a long dash, short dash across the center, and a long dash, right? Now, as I said, if the line gets very long, we can't necessarily do that. So here's an example of a longer center line where it's long dash, short dash, long dash, short dash, long dash. But notice it starts with a long dash, ends with a long dash, both at the top and bottom, right and left. Keep in mind, when center lines intersect, it really doesn't matter whether you cross the long dash or the short dash. If they're small, it'll do the short dash, but when they get longer, it's distinctly possible that the long dash will be where they cross, and that's fine. As I mentioned, center line should extend beyond the surface. Right? So in this case here, you see that the center line is extending beyond the object, right? So this isn't a part of the object that's sticking out, right? This is the center line to show it's a center line that extends beyond. You do not want to do this. You do not want to trim it so that it hits at the edge. That's confusing. That is this a center line or does this represent something else? This is the dead giveaway that this is a center line that is extended beyond. So this is the correct method. This is the incorrect method. And in terms of how they extend, as I said earlier, about 3/16 of an inch is what they shoot for, about 2 millimeters. But again, it's what looks good on your drawing. But they should definitely extend some distance beyond the surface of the object. Now, let's say you have two circles that are on the same height, right? So these are two holes and they're aligned. If they're in the same view, then we can have a center line extend right through these two. And this tells the person that this center line is going to be the same for both of them. So we know these two holes are aligned at the same height. Right? So as long as they're on that same plane, right, at the same point, they can be connected. Now, keep in mind, let's say we had another view over here with another hole, right? You cannot extend the center line to a different view, right? So center lines can extend within a view, but they should not go beyond that, right? Notice how these are extending past the surface. Right? Just the curved surface. They don't have to go all the way outside the object, just past the surface. Now let's get into break lines. Remember I mentioned break lines are used whenever you want to show something, an imaginary break in this. So for example, this is some sort of connecting rod, right? And obviously this detail on the end is important. This threaded detail on this end is important. But this could be a long, thin member. It could be multiple inches or even feet long. And this part right here is just a regular cylindrical part. So by using a break line, we can create an imaginary break in the object and it can make this part far smaller, right? And that generally will fit on your drawing a little bit better, make it easier to dimension, etc. So that's what a break line is used to represent. That doesn't mean the object is literally broken here. It's shown with an imaginary break, and it's just to represent it more clearly in a more efficient way. Now, as I mentioned, there are a couple different types of break lines. Break lines we've seen so far are these continuous arcs, these connecting arcs. Right? It's a relatively thick line, and it's useful for these short distances. Right? For example, things like that that connecting rod we just said. So this is a simple type of break line, but we can also use these for when you have a long distance. Say you want to break something across a larger distance, you can do this one. It looks a little like a heartbeat, right? And it's got this jog in the middle, 45 degrees down, 45 degrees up, 45 degrees down in it. And this is going to be relatively thin, right? Why there's two types of break lines? Well, it has a lot to do with representation. Keep in mind a lot of these rules were made when you were working with pencils. So if you had a long distance, creating that long curvy part would be pretty hard to do. This is a lot more efficient for long lines. Now, oftentimes in a part, if you're looking at it from a view, it turns out that multiple features are going to align with each other, right? There could be a notch in the side, which is the same place as a hole, that's in the same place as an angled surface on the far end. So if you were to look at that from, say, the side view, then the question is, which line should I use, right? Because there's a hidden line there, there's a center line there, there's a visible line there, there could be a whole series of lines there. Which one should I actually represent? Because I can't have them all, and you don't want to draw them over the top of each other. So in that situation, we use what's known as the precedence of line, or line precedence. And in that case, the more important line is the one you're going to show. So in terms of views, the highest important is a cutting plane line, but that only accrues when you're doing sections. On the other hand, if you're not doing sections, the most important view is going to be the most important line is going to be the visible line, then hidden lines, and center lines. So visible lines is the highest, hidden lines next down, and then center lines. So those are the precedents. If, say, visible and hidden are both there, then you only show the visible. If hidden and center are both there, you only show the hidden. If visible and center, you only show the visible, right? So that's what I mean by precedence of lines. And again, the more important one, usually the darker one, is the one that's actually going to be represented. So let's do a quick exercise here on orthographic projection. So let's take a look at this part, right? It's got kind of an H shape here. It's got a hole, another hole. It's got this angled surface here. So it's complicated enough. We're pretty sure it's going to need 3 views. And in terms of this part, the most descriptive is the H shape here. So we're going to use this as our front view, right? Shows us the most. So let's jump into that process. So we've decided it's going to be 3 views, and we've decided what the front view is going to be. So what's the first step in the process? Well, you can start from any view. In this case here, we're going to start from the top view. I actually generally start from the front view, but it doesn't really matter. Start from the top view and work our way down. So the first thing we're going to do is fill in all the visible lines in the top view. And remember, this is the top view. All of these yellow surfaces are shown in the top view. This is a top surface as well, but it's hidden by this other surface here, right? And if we go through and put in all the visible lines, we're going to see this hole. Right, we're going to see this outside edge, and we're going to see the surface here, this surface here of this cut surface. We then go to the front view. Remember, we said the front view was this H surface, so we're going to do the visible lines on this one. Right, and again, we see this H surface here, right, shown here. Boom. But when you look back, you also see this inclined surface here, right? So this is the top, and this is the right side. Moving on, we're going to fill in the visible lines in the right side view, right? And if you're looking at this right side view, you're going to see this angled surface, and then you're going to see this back wall back here. Now there's other stuff that has to be represented, but these are all the visible lines. Next step is fill in any hidden lines, right? And we'll do the front, top, and right side views. So in terms of hidden lines, we have on the top view, with this hidden line representing the back surface of this notch. We have this hidden line here representing the holes, right? And then we have the holes and the notch represented in this side view here, right? So these are all the hidden lines, right? You'll notice they connect at notches, they touch the edge of the surface correctly, etc. So they work pretty nicely. And all the notches are around 1/4 of an inch. I should say the dashes, not the notches. Lastly, we're going to draw on our center lines. Boom. There's our center lines for our hole, right? Top view. There's the center lines for our hole. Now these two holes are aligned, so the center line continues all the way through. And then again, the center line continues all the way through. That's for our two holes, one in the top surface, one in the bottom surface. And you're probably saying, well, why did you just have it go all the way through? We want to make sure people know that these two holes are aligned. And by using this center line going all the way through, those two holes definitely are on the same alignment. If it wasn't important, if they were aligned, you could leave this out in the middle. Now, in this case, we have our small dash in the middle, right? And as I said, the center line connects between the features in the same view because they're aligned correct with each other. Okay, so let's start from scratch. We're given an object and we need to create a series of views. So first thing you want to do is select a front view. So which of these views, A, B, or C, shows us the most about the view? Now, we can clearly leave out B, right? B shows us really nothing. It's a flat surface. Potentially A, potentially C, right? And in my opinion, C is clearly the one to go with. And one of the reasons why is I'm assuming, because the object is represented this way, that this is how it's normally oriented. Right, so I'm going to say C is the front view. That would make A the top view and B the right side view. So side C shows the most about this view, fewest hidden lines, most descriptive, etc. So that's what we're going to use as our front view. Next question we want to ask is how many views do we really need to describe this part? So we have our front view, and then the question is, are we going to have a top view and a right side view or just a top view? Well, clearly we need this top view. There's a hole here. But do we really need this right side view? Right side view here doesn't going to show us a whole heck of a lot, just a flat view. It's going to be a bunch of hidden lines. So in my opinion, we could get away with only two views. And in this case, a front view and a top view. Right? Does that mean you have to do it that way? Well, the fact is you can always get away with doing three views. And in this case, since I'm going to show you the whole procedure, I'm actually going to show you the example with three views. And if you ever have a question, should I do two or should I do three, and you're not sure, go with three, and you're always going to be safe. But eventually you're going to work to be more efficient, and two is a little bit more efficient in this situation. So we start by drawing the visual features of this front view, right? That's this sort of C shape or H shape pattern there, right? So there's our front view. We're going to project upwards for our top view. These are vertical projections. They go straight up off the surfaces, right? In AutoCAD, you'd use construction lines for this. And then we're going to have horizontal projectors that go off horizontally to the right side view, right? We're going to use these lines for creating our top view directly above it and our right side view directly to the right of our front view. Right? Draw in the top view. Right? Here's the left side of the object. Here's the right side of the object. Here's the hidden lines that are associated with this cutout. Here's the hidden lines associated with it. And there's our hole in the top. We're going to project back to the front view. There's our hole, and now we know the two edges of our hole. It's going to be shown here with a hidden line and a hidden line. One technique is to use a miter line or a 45-degree line. Right? You can do this pretty easily. If you draw a 45-degree line off this corner, we then can project from the top view to that line and straight down. So from the top view, go over with a horizontal projector, then down with a vertical one where it crosses, and we can locate the back edge, the front edge, and where this hole is located. Right? And these are going to intersect with our horizontal projectors from our front view, and that allows us to draw the side view, right? Where each of these lines represents a part of the object. This is the outside surface. This is the top of that notch. These are these holes. Notice how the dashes intersect nicely. Now, if you have to project back to do any other parts, you can do that. In our case, we don't really need to. And then the last thing you're going to want to do is put in your center lines. Center lines on this hole, center lines on this hole, and center lines on this hole. These are all the same feature, all shown with the same center lines. Notice how they extend beyond the round part, beyond the object, so beyond the round surface or symmetric surface it's representing. Now, in terms of the views, right, these are going to be adjacent views, front and top, front and right. These two are known as related views, right? Now, clearly the top view and front view are going to have the same width. Clearly the side view and the front view are going to have the same height. Notice, of course, the top view has the same width as, or depth, I would say. Top view has the same depth as the right side view. Right, so these should be equal. You'll also notice the spacing here is equal. Spacing here is equal. Right, the spacing between the views is equal. That has to be done to use our technique effectively. Last thing, we would, if we do it in pencil, you'd erase all that construction lines. If you're doing it in AutoCAD, you just turn off the construction layer and all that stuff disappears. And there's your complete drawing with all the visible, hidden, and center lines. Nicely centered, nicely aligned. Last thing I want to talk about in this unit is about our method of projection. Right? And there's an associated symbol associated with our projection method. In the United States, we use what's known as third angle projection. Right? You may have heard about it when you talk about literature or movies, when they talk about the third person perspective, right? Third angle projection or third person perspective is the idea of a person outside of the object or outside of the situation looking back in. So in our case, if we have an object like this, our right side view, this is the front view, this is our right side view, is going to be as if a person is on the outside looking at the right side of the object, right? So this is a conical surface, and this is the right side of the cone. That's what's done in the United States, and that's going to be the standard for all of our drawings in this class. But keep in mind, in Europe, they actually use first angle projection. First angle projection is similar to the concept of first person perspective, and that's the idea of you looking outward, right? So in terms of our first angle projection for our object here, this conical surface, it's actually as if the person was sort of inside the object looking outward. Or another way to think about it is as the person is standing on the left side of the object looking to the right. Right? And we need to be able to differentiate that. So on our drawings, we're always going to see this symbol right here. This is the third angle projection symbol. Right? It shows up sort of a bullseye with this conical section over here. But in European situations, they actually use this first angle projection where, again, same bullseye, but you'll notice the conical section is oriented differently. That's going to be very confusing. Good news is for this class, we're always going to be doing third angle projection. But if you go out and work in industry, sooner or later you probably will run into European drawings or work with a European company, and this first angle projection issue will come up. So how does that actually affect our drawings? Well, So here's a relatively complicated object, right? We take this front surface here, and that's going to be our front view, right? And if we look at our top surface, this is as if we're looking down at the top of the object, right? Our right view would be as if we're looking at the right-hand side of the object. Left view, of course, all this stuff is going to be hidden because we're looking at the left side. Bottom view, all this top stuff is going to be hidden because we're looking from the bottom, right? But again, these would be the three views we normally use: front, top, right side. On the other hand, if you look at first angle projection, all looks pretty similar, right? Probably doesn't jump out at you right away. Actually, the front view looks exactly the same, right? If we go back, front view and both of these looks exactly the same. But now when we go to the right side view actually looks what used to be our left view, right? Because it's as if you're standing to the left of the object looking to the right. That's our right view. And standing to the right of the object looking to the left is our left view, right? So these views are just interchanged. Similarly, the top and bottom views are interchanged. Now, in first angle projection, in European drawings, we still usually use front view, right side view, and top view. They're just different orientations of the views. So keep this in mind. It's not going to affect anything in this chapter, or I shouldn't in this semester, but it is something that might come up in your CAD career. So let's go over these assignments for this unit. First thing you want to do is read Chapter 3. This is on orthographic projection. Keep in mind there's a whole bunch of engineering essential content associated with orthographic projection. Right? It's on that Engineering Essentials webpage, or you can get it from the downloaded content. For example, they go over an introduction to orthographic projection, the glass box method, talk about standard views, what line types, the rules of line type creation, creating an orthographic projection, applying what we've learned, and they do a series of supplemental problems. So you definitely want to take advantage of those videos, right? In terms of what you have to hand in, there is a series of tutorials. There's the intermediate orthographic projection and missing line tutorials. They're going to be due on Friday, right? And then you have your drawing problems, P3-3, P13-3-13, P3-25, and SP, special problem 3-1, right? And finally, when this is all done, you also have your quiz, and this is going to be due on Sunday. So this is what the tutorials look like, right? This is the intermediate orthographic projection one, right? So it can be done by hand. Can be done in AutoCAD if you want. Any of these can be done in AutoCAD, but feel free to do them by hand. I'm not going to give you additional points. They don't have to be perfect. They're going to be sketched, right? But you have a front view, top view, side view. Exercise 3.7-1 is going to be about missing lines, right? So they give you this problem. Again, I encourage you to use the worksheets in your book. They have nice grid lines on them, and you're just going to fill in any missing lines. And then exercise 3-7-4 is our drawing an orthographic projection, right? And again, it's completing these three views, right? Information is given. Again, things should be nicely aligned, should be nicely spaced out, but can be done by hand. Then in terms of the drawing problems, you're given a series of 3D objects and asked what the views are. You got to match them up, right? You can then do drawing problem 325. That could be hand sketched, right? Here's another drawing problem. Here's special drawing problem 3-1. That could also be hand sketched. Notice in this case here, you only have 2 views. You could always do a third view, but you can get away with only 2 views here. Right, so these are the problems that are associated with Unit 3 that need to be handed in.